C++ tutorial written by Daniel Charles Foreman. Introduction. Today we're going to take a look at a traditional approach to programming and start with what is typically the simplest program to perform in computer programming. The Hello World program has been used since 1972 when it first appeared in Tutorial Introduction to the Language B. Its purpose is to check the new compiler setup is working correctly, and it's a way of teaching new users the simplest syntax and program structure they need to get a useful result from your program. C++ was invented in 1983 at Bell Labs and is an enhanced version of the already existing language C. C itself was developed between 1969 and 1973. As you've begun to realize, both these languages have long histories and are still in active use today and remain among the world's most popular programming languages. In this tutorial, this tutorial will be split into three sections. The first section is where we type in the source code and get a feel for it. The second part is going to deal with the specific commands of the source code so you get a picture of what is going on. The third part is going to deal with the inevitable jargon used throughout this tutorial. This will include words like compiler, preprocessor, header files, etc. And now let's have a look at the program source code. So we're going to start off by creating a new project as we did in my previous tutorial. So we're just going to click on new project, console application, go, click on next, C++. We're going to give it a project title of Hello World. And we're going to click on next. And yes, it already exists, but don't worry about that. Click on finish. Yes, I want to overwrite it. Yes, I'm really sure I want to overwrite it. As you see, it gives you many chances to change your mind in case you've chosen the wrong file name. But as you can see here, our code has already been entered for us. Now what I'd like you to do is highlight all of that with Ctrl and A and press delete. It's quite important to type out source code yourself because it invokes a different kind of muscle memory. I often find myself typing in programs without really thinking about it, simply because I've done it many times before, and you'll be amazed at how this helps memory recollection and how it allows you to connect different subjects in your own mind. So rather than just using what appears on screen and taking the easy way out, I'd like you to get your hands dirty and type this program out yourself. So we're going to start off with the include command. And we're going to type in IO stream. You can follow what I'm doing on screen. And we're going to type in using namespace std, and we're going to end that with a semicolon, and int main open parentheses close parentheses, and we're going to add a brace, and we're going to put this brace at the end of the program, and then we're going to put in some extra commands in the middle. So cout left shift bitwise operator, open quote hello world and close quote, and we're going to use a left bitwise operator again, and end L and semicolon, and then we're going to type in return 0 and semicolon. Now I like to put tabs here whenever I put it into a function because it makes it easier to read. But this is basically our program. So once you've typed that out, it should give you a better feel of what's going on. And if we compile the program, hopefully I won't embarrass myself with a horrible mistake, which I have. Should be a little r, I think. So there you go. One thing to remember about C++ is no typing error, no capital letter in the wrong place or anything else goes unpunished. So you must learn C++ syntax in its exact form. Unlike BASIC and other more liberal, easygoing programming languages, it does pay attention to case. So my just putting a capital R there causes the whole program to fail, and you will come across that sort of error many times. But now that we've established that this program is in fact working, let's have a look at the separate commands. So we're going to have a look at the include command here. Include instructs the preprocessor to include the content of the specified file as if it's been written into the program directly. It is a fast and easy way to include a lot of information into your program without having to write it yourself. In this case, it's including the file IOStream, which is part of the standard library set for C++. So that's the second bit there. This is the file we're calling IOStream. It is a header file which is used for input-output operations within C++. It is part of the standard C++ library and stands for input-output stream. As you can guess, this library provides basic input and output services for C and allows you to use objects such as sin, count, sir, and clog. For this program, it will allow us to use the cout function, which you see down there. Then we go on to the next line, using namespace std. This line allows us to group together a set of global classes, functions and objects under a single name. By using this command, we remove the need to define std before the command. So without this command, we would actually have to type in some extra data, std : before it will work. So we don't actually have to do this because we've called this particular command. So it becomes quickly useful. Some programmers consider this to be bad practice. They would prefer you to put std : before the cout command, as it can get confused with various other namespaces and cause various problems if you got that sort of thing going on. But as CodeBlocks provides this example as default, we're just going to stick with the style of programming they selected for this tutorial. Int main, which is this command here. Int main, this is your first ever function. It is the function which indicates the starting point on your C++ program. No matter where the int main open parentheses, close parentheses, is located in C++, it will always be your starting point in the main program. So no matter how many functions or anything you put before the main, the point where this program always starts is at main. So if I created another function called my function or whatever and put it before int main, then the C++ program will still start at int main. So it doesn't matter where in the program it is, it's always going to start with this particular function. So next we've got the brace. Now the brace commands, you'll see they've highlighted it in blue here. You'll notice that they surround the entire function. The open brace marks the start of the function code, while the last brace, or the close brace, at the end of our code, marks the end of the code. By adding these symbols, C++ knows what source code goes into the main function. This allows additional functions to be created at any time while making it clear to the compiler where the beginning of each function's code starts and where it ends. So all we're doing is marking the start of the function code and the end of it. Next we got this rather complicated line, cout, left shift, open quote, hello world, close quote, then left shift, end L, and semicolon, which might be slightly mystifying. We'll break this down into its elements. We got cout. Cout is part of the IOStream library. It is responsible for displaying data to the screen. So that's quite simple. All it's doing is all it's doing is providing us with a venue or a channel to actually print the text on the screen. It is the only visible part of the program which occurs. Everything else is fairly invisible. Now we have a left bitwise operator, which is the double arrow. This is called left shift specifically. However, this particular left shift has been overloaded in the standard or STD library, meaning that its meaning has been changed, and now what it's basically doing is inserting data into the cout stream. Hello world is the data that's being pushed into the cout stream, so that's being shunted onto the console's window. Then we've got another left shift, and again all it's doing is pushing the next command into the stream. End L, this command inserts a new line character into the command. So rather than having all the text on the screen appear straight after what we've typed in, we're basically instructing the console to go down to a new line so everything is easier to read. The semicolon is part of the C++ syntax. It indicates to the compiler that the command is over, and to treat it the next line as the new command. So if I was to do this, see how I'm separating it all? Now if I do a quick compile, it still works as exactly the same as before. So all this white space we've added into our program itself is completely ignored. It doesn't exist until that semicolon is hit. So if I was to just leave out the semicolon there and go straight on to return, then it would indicate return was part of that ongoing command sequence and produce a whole host of wonderful errors which you do not want. So this is basically marking the end of the command. It's saying that everything here is one line, and that's what we and that's basically marking the end of that line, so we can go on to a fresh command. Return 0 is the final command in our program. It indicates that the function has ended. Sorry, it indicates that the main function has ended. It's the most common way of indicating that a console program has ended, and by returning 0 indicates that the program has functioned as expected. Now we're going to go on to some jargon and terminology that I use throughout this tutorial. The first one I'm going to say is header file. A header file allows users to separate elements of their program into separate reusable files. In this program, it's used to call the standard functions from a pre-made library file, allowing the program to add certain abilities and commands without the user needing to code them themselves. This allows your programming life to become much easier, especially when you start writing customized functions that you wish to add to other programs in the future. You can just encapsulate them into a file and include them that way. So that's all this include is doing, is it's calling the IO stream header file. Functions provides a way of grouping commands together under a logical heading, which can be called from a single line within your main program architecture. So this line here into main, if I was to create a second function called well, whatever, I'll call it my function if I like, then I could just add in the line my function into my main, and that would then execute the commands within that function. So for instance, can you imagine writing 10, 20 or 100 or even 1,000 lines of code every time you wish to perform a specific series of actions? Especially when you've written that code once before, there's no point rewriting it and rewriting it. By encapsulating this code into a function, it means we can reduce thousands of lines of code into one command, which then allows you to call it at any time in the program. So if you wrote a function that's 1,000 lines long and you needed to recall it, sorry, you needed to reuse that code, say, a dozen times throughout your program, then you've just added 12,000 lines of code to your program. Instead, by adding it to a function, we can reuse that same block of code under a specific name and then call it that way. A library file. A library file is a collection of resources used in your computer programs. It allows the sharing and importing of resources across one or multiple programs to be used and reused as often as you wish. You can either write your own library files or use the existing library files in the language you are using, in this case C++. For instance, say you are producing 3 programs: an alarm clock, a media player application, and a computer game. The common element between these very different programs is that they each play an OGG file. The alarm clock plays an OGG file while alerting the user that a specific time has arrived. The media player plays a selection of OGG files depending on whichever file has been loaded by the user, and the computer uses OGG files to produce sound effects. By using the OGG library files, which you can download with each of these programs, I can insert command sets and call and play these files as often as I like without having to explain to the computer myself how to read and play OGG files. So there are many library files out there in the world and covering many different things. So rather than having to code absolutely everything yourself, all you really have to do is go off, find the correct library file, import it into your program using the include command, and you will have those commands and functions that someone else has written at your beck and disposal. The advantage of OGG, of course, being open source, so you could include that with any of your programs free of charge. The preprocessor, which I mentioned, the preprocessor commands are always recognizable by the hash symbol that precedes them. So we got the hash symbol there. In C++, the preprocessor itself is a separate program invoked by the compiler, which includes extra source code definitions and conditional inclusions. This basically allows the users to load extra source code and resources into their programs. Without the preprocessor, we couldn't include the extra library files and header files without adding to the main source code itself. So you'd have to open up those files, copy all the code, paste it into your program that way. So the preprocessor allows us to add all that information without ever opening the file, just by giving the file a name. The compiler is the root of any programming language. It is responsible for transforming source code into assembly language or machine code. Without it, all you got is a block of text and nothing to actually do anything with it. An object is an entity which can be manipulated by commands in programming languages. These include variables, functions, data structures, and classes. Parentheses, which are the brackets here, well, that's basically it. These are what are called parentheses, and these are what I'll refer to them in future. Brackets are these symbols here. They're also called curly braces and curly brackets as well. We've got these symbols here, which is the left shift operator. Is a bitwise operator, which we won't go into right now, but for this tutorial obviously it's been overloaded to mean something quite different. But if you wish to refer to the name of these symbols, and left shift is a good as way as any. Excuse me. Stream in the standard library is used in this program. A stream is an input-output channel linked to the text environment, in this case our console. This allows the user to see data pushed into the console environment and can be used to retrieve data from the console environment as well. Overload. The term overloading is used when an operator has more than one meaning. For example, the left bitwise operator in this program has been overloaded, which basically means its meaning has been replaced by the standard library, that's the std library. So instead of meaning left shift, it's shifting data into the cout stream, inserting the data into the command so that it can be replaced on screen. So if you enjoyed this tutorial and you found it a little more illuminating than the numerous hello worlds out there, then please comment, rate, give me a positive thumbs up and subscribe to my channel. I will be continuing with these tutorials. I will release them as frequently as every week, maybe every month, depending on the complexity and research I need to do into the tutorial itself. As you can see, I like to be quite thorough about it. But if you subscribe to my channel, then you'll never miss a new tutorial uploaded. If you're interested in learning XHTML, HTML, or even HTML5, I will also be producing tutorials on that subject. I will be continuing with my usual tutorials in Dark Basic Professional and creating a new set of tutorials for Dark Basic Classic. I will also be producing tutorials aimed at game developers with using the Microsoft Visual C++ 2010 and the Dark GDK framework. So a whole set of library files basically dedicated to helping you produce your games quickly and easily. So if you don't want to work with code blocks, or you want to work with games specifically, then check out the Dark GDK tutorials, which I already have some uploaded with, and you can learn from those as well. But you can expect a tutorial at least once a week for the foreseeable future on a range of different subjects. So I hope you've enjoyed it. Please comment, rate and subscribe.